Hey guys, what's up? Eddie Alho here with KissAnalog.com. So, we talked about the 10 features you need to know about, or at least I feel like you should know about when selecting an oscilloscope. And today's video is about getting that awesome scope for under $1,000, well under $1,000. Not an entry-level scope, but an amazing scope that you'll love. What's an entry-level scope? I don't know. Entry-level scope. Tektronix, Siglent, they have their low-cost scopes. They're pretty full-featured, but maybe not as full-featured as their more expensive scopes. Maybe some people call them entry-level. I'm going to compare, let's see, I've got some notes here. Keysight DSO X1102. I'm going to compare that to the Tektronix TBS 1202B. And then I'm going to show you the scope I picked out that's even less money than those two and many more features. And I also believe, from what I've experienced so far, that it is very high quality. So, not an entry-level scope, well under $1,000. So let's get to it, and I'll show you. I'll walk you through the 10 features and show you why I feel like this scope is definitely on the list of great scopes at well under $1,000. Okay, I think it's worthwhile to at least talk about features of scopes today compared to great scopes, say 15 years ago. Power supplies haven't changed all that much since then. They've changed a lot, but you know, the signals we're looking at, the speed of the signals and so on, haven't changed that much. And audio, well, that hasn't changed a lot either. So scopes that people considered awesome scopes then, not entry-level scopes, but awesome scopes, I would buy at half price, right around $3,000. And I actually had both a digital storage scope, which I thought was really cool, but it wasn't great, so I also had an analog scope. And they're both Tektronix. They're both, the digital scope was a 2430, I believe, and the analog scope was a 2465, was it? I don't even remember the number anymore. Anyways, a 300 meg scope. It was a great scope. The analog scope was awesome, but it didn't do everything I wanted, so I had the digital scope. I didn't feel totally confident with that. So I had both scopes. I got rid of both those scopes, and I haven't had a great scope for a long time. I have a handheld scope, Tektronix, which has isolated channels, works great for me at home for my consulting stuff, but it's starting to get old, and I thought, well, it's time for me to jump in and get a full bench scope again. So I went looking, hoping I wouldn't have to spend a lot of money. Really, I wanted to spend under $1,000, and maybe I was being cheap, but once I started looking, I realized I could get a scope well under $1,000 that would do much more than those two scopes I owned 15 years ago, which were at that time considered very nice scopes that people would not have considered either one of those scopes an entry-level scope. So when I hear entry-level, I kind of wonder, like, what I think what people are talking about entry-level as far as the price point. But when you look in the dictionary, and I think what a lot of people think of when you say entry-level, it means, you know, kind of a beginner, kind of something you're gonna grow out of. This scope I have, other than what I ended up choosing was 2 channels. Other than that, you know, it's not an entry-level scope. This is a full-featured, awesome scope, and let's go jump into this next piece and we'll discuss it. Okay, so one more reminder. At the end of this video, I'm going to talk about the scope I chose and compare it to the Keysight, which used to be Siglent, which before that was HP. And anyway, the Keysight scope took to the Tektronix. Both great scope manufacturers. Tektronix, I've always felt, been on the top. Agilent was right there with them, or Keysight, sorry. I barely got used to calling them Agilent, now they're Keysight. Don't know why they ever got rid of the HP name. Anyway, both great scopes, but I really believe the scope I chose is a better scope. Less money, more features, and just to tell you what the game changer is, it's deep memory. Tip. Okay, thank you. By the way, kissanalog.com. I just bought the URL. I'm going to build that website, and it'll be up and running soon. I'm just getting excited about YouTube, and used to teach electronics, by the way, back when, industrial electronics, and I really enjoyed that. It was in North Carolina. I live here in Utah now, and kind of looking grubby. Came back from vacation and haven't quite cleaned up. Got a haircut today, but anyway, so here, let's get into what we're going to talk about today. I talked about the 10 key features of selecting the scope, and let's see if you can see that. That's just a reminder, if you can see that. I don't know if you can or not. I'll just read it to you. Anyway, I had to choose a scope for my new lab. I decided to get digital. I love analog scopes, but you know, it's hard to beat a digital scope. Today's technology, it's a game changer in scopes, so it's really hard to argue with the good digital scope. Deep memory is an important aspect, which I had listed at number 4 here, because really bandwidth, the real-time sampling rate, and deep memory, they're all intercombined. You can't get one without, well, some scopes don't have deep memory, and that's what makes some digital scopes a little bit sketchy, in my opinion. I've used scopes through the years, and you know, I've been doing this for a long time, and before they came out with deep memory, I just never trusted the digital scope. The deep memory and the bigger screens, I just love them. They're great. So deep memory, real-time sampling rate. So bandwidth. Okay, bandwidth of a scope. If you're an audio guy like I am, that's my hobby, audio amplifiers. 20 kilohertz sine wave. It's as high as most of us can ever hear, and I'm sure I can't hear that high anymore. But anyway, 20 kilohertz. Okay, so let's say you want to hear, let's say your bandwidth, you're looking at, you want to get 20 kilohertz, right? Well, wherever your bandwidth is, you're 3 dB down at that point. So basically the way that works is if you go 1 decade before that, so let's say you're at 100 megahertz scope. If you go 1 decade before, which is 10 megahertz, a decade below, you're pretty much at your flatness. It's about half the frequency of your roll off that you're about 10% down. Yeah, I think that's right. So if you're 100 meg, that means around, so if you're 50 meg, that's where you're down about 10%. So anyway, you know, going back to analog or audio stuff, 20 kilohertz, that's not very fast. So any scope can pretty much do audio, any good scope. But then there are digital aspects to audio now, and those digital aspects that you might have faster clock cycles, you might have switching power supplies, and let's say most switching power supplies, they're going to be well under a megahertz. Some of the switchers operate at megahertz or above. They're really the lower, they're really what they call point of load regulators, not regulators that you're going to power an audio amplifier with. So audio amplifier, you're probably talking about a power supply maybe operating around 200 kilohertz. So 200 kilohertz, you know, you could get a scope that's you know, a megahertz, and it's going to give you good waveforms. But when you start looking at the rising edge of the clock cycles that turn on those switching FETs, now you're talking about, you know, a faster signal. So when you're doing that with power supplies, 100 megahertz scope is a good scope. I ended up choosing a 200 megahertz scope. Okay, so let's say with 200 megahertz scope, another important aspect is real-time sampling rate. That's a digital aspect. That's a discrete part of the scope, a digital scope. An analog scope is continuous. A digital scope is discrete. So you want to make those discrete steps into a smooth analog step. And to do that, you have to be sure you're following Nyquist's theorem, which says you need 2 points for every cycle and frequency. So, and most scope people, or at least the good ones, will do 2.5. So let's say you're 200 megahertz bandwidth. That would mean that you'd want a scope, you don't want the bits, you'd want to get at least 2.5 bits per cycle of that. And so, okay, so I guess we're going to get into the math part of this. Just before we do that, the other aspect of this, just to kind of fold all of the parts in, it, you know, that makes the digital sampling scope great, is the we're talking about deep memory, refresh rate, and sampling rate. Those three things combined. The refresh rate is how fast your scope's going to refresh after it's sampled a whole bunch of stuff and it's ready to, it's processing, it's ready to start gathering more information. That's refresh, how fast it can refresh all that, you know, keep that digital data flowing. And so that's an important thing, because you don't want to miss something in your signal that happens during the time that can also be called dead time, in between the time your scope's working on digitizing information and the time it's ready to gather more information. So that refresh rate, you know, is an important thing. Okay, so I'll just jump into it. The 200 meg scopes, you want at least 1 gigasample per second. Okay, a 1 gigasample per second scope, it's going to divide in two for your 2 channels, the 2 channels I decided to get. If you get 4 channels, they'll usually have one of these processors for each 2 channels, so it'll be the same math. So let's say you get 1 gigasamples per second. Well, some people might give you 2 gigasamples per second. That might be more than what you really need. Nyquist, if you're looking at Nyquist, 1 gigasample is going to be more than enough. And let's just go through that. So 1 gigasample, you're at 500 million samples per second for each channel. Okay, 500 million. So that's 2.5 times 200 million for your 200 megacycles. So there you go. That's your 2.5 bits. That's over and above what Nyquist says. He says 2. So really 400 million bits per second, so that you're getting 2 bits for every cycle of your 200 megahertz would be enough per Nyquist. But anyway, 2.5 is usually what they shoot for. So that's your bandwidth and your real-time sampling rate. That's how they get intertwined. Your bandwidth can kind of mess that up too if that's an analog portion of your scope, and if that doesn't have the right, you know, components, that it might limit it. But I think most of these scopes today, most reviewers, I haven't seen anybody say that they've reviewed a scope that doesn't get the bandwidth. So I haven't seen one. Let me know, comments below, if you found cases where that's not true. But it seems like kind of an easy thing to do with your analog section, is to get 200 megahertz bandwidth. Anyway, with the 200 megahertz bandwidth, 50% of that down to 100 megahertz, I can be sure that I'm within 10% of my amplitude when I'm reading it, because as that filter rolls off at the high frequencies, At 200 meg, it's going to be at minus 3 dB. At 50% of that, 100 megahertz, it's going to be about 10% down. And at a decade below, which is 20 kilohertz or 20 megahertz, it's going to be pretty flat right there. So that's kind of how the roll-off works. So that's the bandwidth portion, and that's how it's intertwined with the sampling rate. Deep memory is so important. If you're zoomed in on a signal and you're watching that pulse, you're fine. But if you're sitting back watching many or several pulses or many pulses, because you might want to see the low frequency oscillation that this high frequency stuff is riding on. You get this high frequency signal, you're looking at it close up, it looks like, wow, okay, I caught it. Another aspect of that is your trigger level might be set at a higher level, so you're capturing every, let's say, 10th cycle that's a high peak, and it looks like, oh, they're all this way. But you zoom out and you go, wow, no, that's every 10th cycle is this high. The 9 before were all down here, and then it popped up, and then it popped up. And so you want to zoom out to see. You don't want to be so focused down in your circuit that you're missing the bigger picture. So you want to pull back, look at a bunch of cycles, and even pull back even further to see low frequency stuff, 60 hertz, 100, let's say your power frequency stuff coming through. You want to look at all that stuff. At the same time, when you see something, you want to be able to stop it, zoom in, and know that you're capturing good data. Deep memory is how you do that. Before deep memory came out, which, by the way, a lot of the scopes out today, a lot of the inexpensive scopes today don't have the deep memory you need. We're going to talk about that here in just a moment, and I'm going to show you that. 2 channels, phosphor color, fast Fourier transformer, FFT, really important, so cool. I'm just so impressed with that. I was so excited when we got our first scope that did that. Again, Keysight DSO X1102, Tektronix TBS 1202B. I hope you can see that. That's kind of how they compare. 100 megahertz, pretty good. I mean, these are pretty darn good scopes for right around $1,000 or less. I mean, pretty amazing. 15 years ago when I bought a used scope, it wouldn't have done this for, and I paid a lot more for a used scope back then. But okay, let's go into this scope I actually chose, and then let's compare them against those two. Hey, by the way, before we jump to that, I want to show you a picture of the Keysight. Okay. What's nice about this Keysight scope is it has a vertical channel, then it has a horizontal channel, and then it has some other waveform here, and then a trigger here, and then it puts the trigger on the far right, but then it puts the acquire menu across this, which that's one thing about HP, Agilent, or Tex that have always been a little different than Tektronix. Tektronix is always, and it's just what I'm used to, I guess, but so the Tektronix, okay, it puts the vertical scale, the horizontal scale, then it has an acquisition next to it, and then the trigger next to that. So it puts them all in line. And then up above it has all the cursor and special functions, where HP or Agilent or Keysight, it kind of moved that acquire portion of the scope up there. Okay. Now, to look at the two side by next to each other, kind of a picture of them. When you look at the picture, it would appear that the Keysight monitor is much larger, but it's not. It's just that it has a dark border around it. They're both 7-inch screens. Keysight, I think, did a nicer job in the design of their scope. It just looks nicer. They're both very similar features. Besides the features I discussed, they both have a few more features, really cool features that they've added. You know, they're not the kind of things that you know, that you'd compare to an old analog scope or something, but you know, they just got some niceties, some extra bonuses. You know, touch buttons, soft key buttons, they both have those kind of things. They use you know, they're both lightweight scopes, 4 pounds, right around there. So now let's go to the scope I chose, and let me show you why. I chose the Siglent scope, and that's after looking at a bunch of other scopes too, but I just wanted to compare it to the Keysight Tech because those are really two leaders. So I thought that they'd be good ones to compare. So if you can see this list, maybe you can pause it and check that out. Hopefully you can focus on that. I'll just read it to you just in case you weren't able to see that. They're all digital scopes. That was number 1 on my list of the 10 things. Second one was bandwidth. Siglent's 200 meg, the other ones are 100 meg. So Siglent's, you know, wider bandwidth scope. Real-time sampling rate. Siglent's the 1 gigasample per second, the one I did the math on, and I showed why 1 gigasample was more than adequate for Nyquist's theorem, which is what the whole discrete mathematical, you know, functions are built upon to translate digital to analog or continuous. So anyway, the other ones have 2 gig, and I think they did that. I imagine they did that because of the processor they used on higher end scopes. Because even the lower end scopes have the 2 gigasamples. So I mean, even the lower bandwidth scopes. So deep memory. As a matter of fact, just a note here, the Keysight scope, the one I quoted, 847, you can actually get that 70 megahertz bandwidth instead of the 100 for a little bit less money, about 130 bucks less, I think it was, and it still has 2 gigasamples per second. So that was my point on the real-time sampling rate. I don't think that had anything to do with the bandwidth. I think it just has to do with, you know, the processor they're using. So anyway, deep memory, here's a biggie, and this is really why I chose the Siglent. It has 14 million points. Okay, if you go to Keysight or Tektronix and look at their scope, if you just look at the scopes they offer and you go down and you look at deep memory until they get down to the ones that have the deeper memory, the price goes up 2-3x. So so that it's a big plus. 14 million points with the Siglent. Refresh rate, 60,000 waveforms per second. Keysight was close, it was 50,000, but you know, Siglent beat it there too. And by the way, there's another very important feature which the other 2 scopes don't have, Siglent does, and it's called segmented memory. And that's kind of another aspect of the deep memory thing. You might have some stuff that happens in your signal here, doesn't happen for a while, then it happens again. Doesn't happen for a while, and then it happens again. Well, you just can't possibly have a scope with deep enough memory to score that much information to be able to zoom in and see what that thing was that happened. So they call it segmented memory. It'll trigger on that thing, capture a bunch of stuff, and then sit there idle for a while, and then trigger again, sit there for idle, and then it'll take all those little segments that are captured and put them together, and you can play through it like a video. And that's something Siglent has the other 2 scopes don't have. It's an advanced feature that you'd have to spend probably, you know, I think at least 2-3x on the other brands. So I didn't put that on my list because, you know, that's just a super cool feature that you get with something that has deep memory, which is well above what I thought I was going to be able to afford when I was looking, and then turned out Siglent had it. Anyway, 2 channels, all of them. You can get 4 channels in the Siglent, and you can go, you know, they all have higher bandwidths and more channels and stuff like that, but, well, actually this Keysight, I think topped out 100 meg. I think you have to go to the next series to get a faster bandwidth. Tektronix, I think that may be true as well. Actually, I think you could go to 150 megahertz bandwidth on that, but it was even more money. So I wanted to kind of keep the playing field. That's why I chose 100 meg on the other two scopes, is to try to keep the price down to kind of the level that I was looking at. But I went up to 200 meg on the Siglent because it's so affordable. It does have phosphorus with color, so huge plus for the Siglent. Phosphor with color. That's really cool. And I'm going to demonstrate why that is in some videos in the next few days. And FFT, Siglent, you can do the split screen that the other two do, but you can also do a single screen, so you can just use the whole, size of the screen to look at your FFT, which is really big. It has advanced trigger functions. The other two had basic. The Siglent has some other, differentiation, it does integration, and it does, I'm trying to think, square root. Anyway, it does some higher math functions. You would think that, if they're able to do FFT, they'd all do higher math functions, but it turns out it's not true. Siglent does. Advanced trigger functions, Siglent, yes, it does. It'll do the runt. It'll do the pulse width, narrow or wide. It'll do, there's a number of things. Rising edge, falling edge. That's basic, right? But it'll also do it'll do both. So every other, let's say you're looking at square wave. One time it'll do the rising edge. Next time it'll do the falling. It swaps back and forth, so it'll do that too. It has an 8-inch screen. It's an inch bigger. I mean, 7-inch, 1 inch bigger. It's, that's 8 inches. It's noticeable, especially when you've got stuff around the borders. Especially around the bottom. You got, stuff taking up part of that 7-inch screen. So adding another inch makes it noticeably bigger. And the price today is $550. $550. 200 meg scope, deep memory. That's unbelievable. I think Siglent with some other scopes, they're really driving Tektronix and Keysight into these kind of models to try to compete with these people, because technology in these scopes are amazing, but you have to think about that technology in manufacturing and design and chip manufacturing. Everything that goes into making a scope has also gotten less expensive. Your large screen TVs, for instance, look how much less money that you get. You pay today for a 50-inch screen, and they're amazing, right? And they're inexpensive. Why shouldn't scopes be that way? Well, Siglent, Rigol, some other brands you guys are probably familiar with are all doing that. Hey, give me your comments below. Tell me what scopes that you like and what features you think are important. And let's talk about it. And I'll do videos on these features, and I'll demonstrate how to use these features. Now here's my little pad, just in case you see this. I have to edit this later and see if I can actually see that with you guys. And if I can't, I'll do better in my next video. Sorry about this. Temporary setup. I'm just back from vacation, hoping my house is ready to move into, and it's not. So sorry about that. Next time maybe I'll be in my lab. Probably not. I'll probably have a few more kind of strange, or this isn't strange, this is wonderful. I love this place. But anyway, might have a few more videos outside of my home, but because I want to keep them coming. I want to publish videos every couple of days, and I think I'm gonna do an educational video series too. If you guys are interested, let me know. You know, there might be some beginners in there, some people who maybe want to learn electronics, maybe from DC, AC, op amps, you know, all the way up. Advanced people that want to learn how to do switch mode power supplies, audio amplifier design, anything filter design, EMI filter design. I'm surge, lightning protection, you know, anything like that that you guys have ideas on, please write them. So give me some ideas and I'll do the research, try to improve my presentation and try to keep on bringing some good content. And I'm going to really enjoy this. I'm going to give it a go and I'm not going away. So please give me information, okay? Thanks, guys. Hey, give me a thumbs up, subscribe so you can see the next videos coming. I'm going to keep them coming, and I'm going to do some book reviews. There's going to be, you know, I'll figure it out as I go, but I want your help too, and suggestions on what I should do and how I can improve and what kind of things you guys would like to see. I've been around for a long time, pretty good analog engineer, and you know, so please give me your comments. Thumbs up, subscribe. Thanks, guys.